Orientation. Still at S5, but the picture got bigger. You don't run one agent, you run a team of them, handing work to each other. The danger is trust. One agent's output becomes the next agent's input, and if you trust peers blindly, a single compromise propagates across the whole swarm without a human ever seeing it. We'll trace that cascade defensively, then apply zero trust between agents to break the chain. Securing AI S5 agent. Still at the agent stage, but now it's a whole team of agents, and the bug is the trust between them. Defensive only, we show the cascade so we can break it. S0 data, S1 train, S2 model, S3 supply, S4 infer, and S5, the agent stage lit in clay. Same stage as the last episode, but this time the failure mode is the team. In production, you don't run one agent. You run a team, an orchestrator and workers, A, B, C, D, passing work along a chain. Today, handoffs are benign cyan dots. Here's the quiet assumption. Every handoff treats a peer's output as trusted input, the same way naive code trusts a web page. That single assumption is the entire vulnerability. One agent gets injected, the same attack we covered last episode, a poisoned memory, or an injected input carrying obviously fake content. That part is not the news. The news is what happens next. A's poisoned output becomes B's trusted input. B has no reason to doubt a teammate, so it takes the forwarded instruction at face value and acts on it. One compromise just became two. B forwards to C, C forwards to D. Each agent flips, one injection in A, 4 hijacked agents downstream, the cascade. Notice this is a flow, not a recipe. The point is the shape, not the payload. And nobody asked a human. The whole cascade ran agent to agent at machine speed. That's exactly what makes multi-agent setups powerful, and exactly what makes this failure mode fast and dangerous. Fix 1, never auto-trust a peer. Treat every handoff as untrusted data, not as a command. Separate instruction layers between agents. This single change breaks the cascade at the very first edge. Fix 2, scope each agent to its own task. B summarizes, C looks up, D writes. Even if B is hijacked, it cannot borrow C's lookup powers or D's write powers. Least privilege applied per agent. Fix 3, isolate the agents. Microsegment them so a compromise stays in one cell instead of jumping across the swarm. Same posture as network segmentation, pointed at agents. Fix 4, watch the handoffs. The edges between agents are the new perimeter. Monitor them for drift and anomaly, so even if a layer slips, you see the cascade begin and you stop it. Replay, same injection lands in A, the red dot reaches the first handoff and stops. B reads it as untrusted data, B is scoped anyway. Isolation contains A, the monitor flags it. One compromise stays one compromise. Pull back, 4 green layers across the team, and they're the same 5 zero-trust guardrails we've used all series. Allow known good, readable policy, log everything, fail closed, layer up. Zero trust, pointed sideways. A peer is not more trusted than a web page. The cascade is contained, but every defense here assumed you could name and scope each agent. You can't secure what you can't attribute. Next episode, 0605, Agent Identity. I am for non-human actors. Break it on the board, not in prod. So the cascade comes from trust. One agent's output is another's input, and blind trust turns one compromise into many. The fix is the zero trust posture, applied between agents. Treat a peer's output as untrusted data, not instructions. Scope each agent to its own job, isolate them so a breach can't spread, and monitor the handoffs for drift. Next, the thing that makes all of this enforceable, giving each agent its own identity. Break it on the board, not in prod.